It weighed 57 tons and took 300,000 man-hours to build. Its 88mm gun could destroy any Allied tank it encountered. At ranges those tanks couldn't return fire. It was the most feared armored vehicle on any front it appeared on. It also spent more time being towed than it spent fighting. Of the 1,347 Tiger I tanks produced between 1942 and 1944, fewer than half were operational on any given day, not because of enemy action, because the machine that was supposed to be invincible was, in the language of the engineers who built it, maintenance-intensive by design. That phrase is the kind of thing written in a technical report when what you actually mean is, we built something that cannot survive contact with the conditions it was built to fight in. The German army already knew this before the first Tiger reached the front.
In the summer of 1941, Germany's armored forces encountered the Soviet T-34 and KV-1 tanks for the first time. What they found was alarming. The standard German tank, the Panzer III, could not penetrate the KV-1's frontal armor at any practical combat range. The 50mm gun fired, the Soviet tank kept coming. The Wehrmacht submitted an emergency request. Build something heavier, build something with an 88mm cannon, build something that can kill what we're facing. Henschel and Porsche were both given contracts to develop a prototype. The vehicle that emerged from Henschel's factory at Kassel in 1942 would become the Tiger I. It was, in several genuine engineering respects, an exceptional machine. The 88mm KWK-36 gun was adapted from the Luftwaffe's anti-aircraft cannon, already proven lethal. The armor on the front hull was 100mm thick. Sloped armor was becoming standard on Soviet designs by then. The Tiger used flat plates welded at right angles, which was simpler to manufacture and easier to repair in the field. That last detail, easier to repair, was written into the design specification as a priority. The engineers at Henschel understood something the high command had not yet accepted. A 57-ton vehicle fighting on the Eastern Front would need more maintenance than a tank half its weight. The roads were mud in spring, ice in winter, hard-baked clay in summer. None of those conditions had been accounted for in the suspension system they were told to build. They flagged it. The timeline was not adjusted.
A conventional tank suspension in 1942 worked on a relatively simple principle. Bogies, sets of road wheels, were mounted in pairs along the hull's lower edge. Each pair absorbed shock through a spring or torsion bar. The system was robust because it was distributed. If one wheel failed, the others compensated. The Tiger used something different. Its designers specified an interleaved road wheel system, 3 overlapping rows of wheels staggered across the hull, 16 wheels per side. Each wheel was large in diameter, 800mm, and the 3 rows interlocked in a pattern that spread the vehicle's enormous weight across the maximum possible ground contact area. On paper, this reduced ground pressure and improved cross-country mobility for a tank weighing twice as much as anything it was designed to replace. The problem became apparent the first time a Tiger operated in mud. When the interleaved wheels packed with debris, earth, rocks, ice, the entire system seized. The wheels couldn't be cleaned individually. To remove the outer row for any maintenance purpose, the inner rows had to come out first. In a field repair situation, that meant a crew with hand tools, working in whatever conditions the Eastern Front provided, spending 8 to 12 hours dismantling the running gear before they could access the component that had failed, and then reassembling all of it before the tank could move again. The torsion bar suspension underneath was similarly complex. 74 torsion bars ran the width of the whole floor. When one broke, and they broke with regularity under the stresses of sustained combat operation, the bar ran transversely across the bottom of the vehicle. Replacing it required removing the floor plate. That wasn't a field repair. That was a workshop repair. And the workshops, when they existed at all, were hundreds of kilometers from where the tanks were fighting. The final drive units, the gearboxes that translated the engine's power to the tracks, were the chronic failure point. The Maybach-Ulvar pre-selector gearbox was an engineering achievement. It was also not designed for the loads a 57-ton vehicle produced when turning, and particularly when pivoting on one track, which was the standard maneuver for a tank repositioning under fire. The final drives failed, consistently, predictably. The engineers noted the failure mode during testing in 1942. Production continued. By November 1942, the Tiger had been deployed to 3 separate fronts: North Africa, the Eastern Front near Leningrad, and the sector around Stalingrad. None of those deployments went as the Henschel engineers or the operational commanders had expected, though for different reasons. In North Africa, Tigers encountered sand. The interleaved wheel system packed with it as efficiently as it packed with mud. The air filters clogged within hours of sustained operation. The filters were designed for European conditions. No one had considered that a tank destined for the desert might need different air management. A modification program was authorized. The modified filters began reaching frontline units in late 1943, more than a year after the problem was first reported. On the Eastern Front, the operational picture was simpler and worse. In the winter of 1942-43, temperatures around Leningrad dropped below -30°C. At those temperatures, the Tiger's transmission fluid became viscous enough that the gearbox could not engage at startup. The prescribed solution was to run the engine for 30 to 40 minutes before attempting to move. In a combat situation, with artillery already falling and infantry advancing, 30 minutes was not available. Crews improvised. Some lit fires under the transmission housing. The Army published a technical bulletin in January 1943 outlining the correct cold start procedure. It arrived at some units after the winter had ended. The supply situation was the structural failure beneath all the mechanical ones. The Wehrmacht's logistics doctrine had been designed around a war of rapid movement, fast advances, short supply lines, enemy forces collapsing before attrition became a factor. The Tiger was built for a different kind of war. The war Germany was actually fighting by 1942, a grinding, attritional, static conflict, where a heavy tank's ability to hold a position mattered more than its ability to sprint across open ground. But the Tiger needed a specific recovery vehicle to be towed. The standard SD-KFZ-9 half-track, the heaviest prime mover in the Wehrmacht inventory, could manage it only in pairs or threes if the ground was soft. When a Tiger broke down in the middle of a defensive position, recovering it required pulling 3 vehicles from other duties, a towing operation that itself consumed fuel, and a route back to a workshop that often didn't exist within practical range. By mid-1943, at the Battle of Kursk, the largest tank engagement in history and the operation for which the Tiger was arguably most suited, German records show that of the 148 Tigers committed, mechanical breakdown accounted for more losses than Soviet anti-tank fire. Not slightly more, substantially more. The Panzerwaffe knew. The quarterly maintenance reports reaching Berlin from every front told the same story in the same numbers. A tank with a theoretical combat kill ratio of 5-to-1 was losing more vehicles to its own running gear than to the enemy it had been designed to defeat. The response from OKH, the Army High Command, was to order more Tigers. The Tiger I was phased out of production in August 1944. By that point, 1,347 had been built. For context, the Soviets produced 57,000 T-34s in the same period. The Americans built 49,000 Shermans. Most Tigers that survived the war did so not because they were recovered and repaired, but because they were abandoned. When a Tiger broke down in a position that could not be held, the crew destroyed it to prevent capture. More Tigers were destroyed by their own crews than by Allied anti-tank fire across all fronts combined. That figure appears in multiple post-war Allied intelligence assessments of German armored vehicle losses. It was not a secret. It was simply not the story anyone was telling. Of the 1,347 built, approximately 8 remain in running condition today. The most famous is Tiger 131, held at the Tank Museum in Bovington, England. The only Tiger in the world restored to operational status. It was captured in Tunisia in April 1943 after its commander panicked and abandoned it when a Churchill tank's shell jammed the turret ring. The Tiger was mechanically intact. It had not been penetrated. It had seized up. Here is what the Tiger's story actually is. It is not a story about German engineering excellence. The engineering was real. Several elements of the Tiger's design were genuinely advanced for their period, and the 88mm gun's effectiveness was never in doubt. What the Tiger's story is a story about an institution that prioritized the weapon it wanted over the weapon it could sustain. Every failure mode was documented before the Tiger reached the front. Every logistics problem was predictable from the specification. The men who flagged those problems were not wrong, they were overruled. The tank that was supposed to be invincible turned out to be dependent on roads that didn't exist, workshops that couldn't be built fast enough, and a supply chain that was never designed to support a machine of this complexity. The Soviets built 57,000 T-34s, simple, reliable, fast to repair. Germany built 1,347 Tigers. If you want to know why the next machine on this channel made the same mistake in a different uniform, subscribe. This one will surprise you.